This is 3.8. Which of the following is a net ionic of a neutralization reaction? Neutralization just means acid plus base. That's it. There's no acids. This is metal plus acid. This is just salt and water. It's just dissociation. This one is just two things combining. And this one is just this one's also dissociation. See, it dissociates. It gives away one hydrogen and becomes Cl minus. So this is the only one. Again, they're asking for net ionic, so everything else is gonna cancel out. Let's say it was let's say for example it was HCl plus HCl plus NaOH. NaOH. So just make it overall ionic. So it becomes H plus Cl minus plus Na plus OH minus gives you Na plus Cl minus, because it's aqueous. NaCl is going to be aqueous plus water, which is liquid. Cancel because they're on opposite sides and they're the same. So that's all you're left with. It could be done with any acid. When a reaction between a weak acid and a strong base occurs, basic salt. It's basically I don't really know how to explain. Kind of like, imagine negative and positive. If you have a small negative number and a huge positive number, what's it gonna be? It's gonna be positive, صح? Pretend the bases are positive and the acids are negative. Also, because the pH. So let's say forget pH. Imagine this is positive and this is negative. If this is positive 20 and this is negative 5, it's gonna be positive 15. Which one was positive? Again, the base. So it's gonna be basic. When a strong acid and a weak base, see, again, negative and positive. If you have negative, imagine the acid is negative and the base positive. So if you have negative 20 and positive 5, it's going to be negative 15. And which one was negative? The acid. So it's going to, just look for what's remaining. What's going to be remaining? It's like limiting an excess. The acid, yeah, that's it. It's like limiting an excess. Imagine the acid, imagine being basic and being acidic, we're limiting an excess. So being acidic is an excess, so it's going to be being basic. So strong acid and weak base, equal quantities. The resulting solution is acidic, and it contains more H plus than OH minus. If something is, you can get this part without the first part. Completely ignore the first part, you can still get the last part. When something is acidic, what does that mean? That means power of hydrogen has a good amount, it has a lot of pH. Also, when something is acidic, that means H plus was released. HCl, for example, gives you H plus. Even if it's as soon as you see acidic, it means it has more H plus than OH minus. Yeah, look, if something has a really low pH, yeah, so ignore this. So acidic, so that means pH is less than 7. So let's say the pH was 2. So that means, again, hydrogen is 10 to a negative pH, so it's 10 to a negative 2. So that means OH is 10 to a negative 12. Imagine 0.11 zeros 1. That's the difference. Salt produced by a strong acid and a weak base is acidic. Salt will turn wet blue litmus. Yeah, okay, this is common sense. So litmus paper, I don't know my screenshot. Salt produced by the reaction, again, strong acid and weak base is acidic. So that means the salt will make litmus paper red. It's just memorization. It's just common sense, not even memorization. When a strong acid and a strong base react in quantities equal number of moles of H plus and OH minus, a neutral solution is produced. So when H plus is equal to OH minus, the higher OH minus is, that means it's basic, and the higher H plus is, that means it's acidic. When they're equal, remember KW is what, 10 to the negative 14. So if you divide that in half, because two of them have to be equal, that means both of them are equal to 10 to the negative 7, yeah? And again, 10 to the negative pH. pH is 7, so it's neutral. A neutral salt could be prepared by mixing a strong base with a strong acid. If you're trying to that's the whole point of neutralizing. You're trying to get rid of the acidity or get rid of the basicness, whatever. So what else can you mix with a strong acid to get a neutral salt?